So I'll use the letters G to represent the scores of each of these 4 girls, and B is that for each of the 6 boys, and they tell us that they have the same marks. So the first relationship would be that their total scores would be, sum of the total scores would be 4G plus 6B, and that would be equal to the average times the number of terms, which is 10. We have 10 boys and girls together. So that's our first relationship, and I can reduce this by dividing by 2. So it simplifies to that. Now the next condition is that the marks of any girl is at most double the marks of any boy. So it has to be less than or equal to. And it's also not less than the marks of any boy. So it has to be greater than or equal to B. It can be equal. It just can't be less. So these are my 2 conditions, and then I need to find possible integer values for this 2G plus 6B value. And you'll notice here that I can split this into 2G plus 3B plus 3B because we have this already equal to 120. So that's 120 plus 3B. Another way to simplify that. Now what we'll do is to see what constraint does it put on one of these variables, either B or G. So I'm actually going to use B, but you can use either one. And that means B is 40 minus 2G over 3. So I'll solve these inequalities individually. So B is, first I'll do this set, 40 minus 2G over 3 less than or equal to G. So add 2G over 3. So that's 5G over 3 divided by 5. So G has to be greater than or equal to 24. And then we have this other one. We'll do the same thing. G is 2 times 40 minus 2G over 3. So that's 80 minus 4G over 3. Move that term. So 7G over 3. So G has to be less than 240 over 7. And if you divide this, 7 times 3 is 21, 28. So I think, let me just make sure, 7 times 3 is 21. Yeah, remainder 2. So G is greater than or equal to 24, less than or equal to 34 2/7. Now, G and B can be non-integer. I think we just have to look at this piece here. So since I know about G, I'll actually rewrite this in terms of G actually. So instead of doing that, because it's 2 times 3B, and from this relationship, 3B is 120 minus 2G. So I'll replace that here. So that becomes 2G plus 240 minus 4G. So the expression that we're looking for, the integer values, reduces to that. So we need to figure out those values of G for which this is integer. And you'll notice that G can, of course, take on integer values. And if I list those out, 24, 25, 26, all the way to 34. So those are 11 values. That would be acceptable. That would make this integer. But notice, because we're doubling that here, the half values in between would also work, which means G could be 24.5, 25.5, and all the way to 33.5. So these also will work in addition to the integer values for G themselves. So that, if you count, that is 10 more values. So if you add those up, we have a total of 21 possible values for this expression. These are the different G values that would satisfy this constraint and that constraint here, and that would result in this expression being integer. So the answer is 21, choice A.